All right, mathletes, we're going to do something that you're just going to love. It's going to be amazing. You're going to be so happy. It's called Gaussian Elimination. So this is another way to solve a 3x3 matrix, or a 3x3 system. We've learned substitution, elimination, and now this is a different way, which is called Gaussian. It's another way. So we're just practicing it. You're going to ask questions, of course. My main goal is not that you're going to be like a super master of this, but that you can kind of understand the process. Okay? So on the first one, back substitution. So this is like the little first part of our notes here. So if we look at a matrix, this first box, or this first like little column, this is x's, this is y's, and this is z's. X, y's, and z's. Okay? So what this means is 1x equals 12. So x equals 12. That's what that means. This means that 1y equals negative 2. And that 1z equals 4. That's what this means. And when you do a calculator matrix, that's what it means when it gives it to you. Now let's go ahead and look at this next system over here. So this is a matrix, and the difference is now I don't have all these ones, I have this stuff. So to solve, we just have to do back substitution. So that means here, this is the z's, right? Remember x, y, z. So those are the z's there. So what that basically means is 2z equals 6. Well, I could solve that. I would just divide by 2, and doesn't z equal 3? Yeah, z's 3. Boom. Okay, so I get z. Now I have to go find x and y, correct? Well, I do back substitution. So basically I go back to this equation. This is 0 x's, no x's, but it's negative 2 y's, right? So I'll do that here. Negative 2 y's plus 3 z's. Well, you told me z was 3. So I'm going to put a 3 there, and then it's going to equal 9. And then I just solve it. So negative 2y. 3 times 3 is 9. I subtract 9. Negative 2y equals 9 minus 9 is 0. I divide by negative 2, and y equals 0. Love it. So I have z is 3, I have y is 0. Then I have to go back one more time. Back substitution to this equation. So this is 3x's. Plus 2, and then the y's are 0, minus 1, but then the z's are 3, equals 12. And then we just solve it. So 3x comes down. 2 times 0 is just 0. Negative 1 times 3 is negative 3. We add 3, which is 15. We divide by 3, so x is 5. Yay, I have x. So I'm going to write my answer as a point. So x is 5, y is 0, and z is 3. Perfection. Okay, so those are the notes for those ones. I want you to go ahead and, in class, we just did these two on the bottom on our own. So just plug in and go from there. Okay. If you're doing it right, though, let me go ahead and give you the answers. So I'll pop this up in 1 second. So there you go. Those are the answers there in red for you. If you didn't get them right, try again or come talk to me. Okay? So we're going to solve by Gaussian elimination on these. We're just going to do one example here in these notes, but of course if you need extra help, come see me for practice. And again, my main goal is that you've tried it, we're experiencing it. I'm not expecting you to be like a master of this after just like one lesson. So the first thing we're going to do is we're going to make our matrix. So I'm going to make my little matrix here. I'm going to draw my line. And just like you would type in the calculator, that'd be negative 1, negative 4, 6, and negative 27. So negative 1, negative 4, 6, negative 27. That would be 1, 5, negative 3, 24. And that would be 3, negative 3, negative 2, and 4. Beautiful. So when you're doing Gaussian elimination, the first thing we have to do is get zeros here. Either here or here. One of these two numbers here has to be a 0. So if I look, and if I kind of don't look at this bottom equation right now, if I add these equations together, negative 1 plus 1, that looks like it's going to give me a 0, right? Negative 1 plus 1 would be 0. So that's what I'm going to do. I'm going to add this first equation and this second one together. So how I write that is I'm going to do row 1, I'm going to add it to row 2, and since I want my 0 to be here, I'm going to put it into row 2. So again, the reason why we want zeros here is because if I look up at that back substitution stuff, once I get zeros in these 3 spots, then I can just back substitute and then I'm done. Okay? So that's what we're going to do. So I'm going to draw another little matrix. I'm going to take my numbers here. So -1. Okay, so I'm going to rewrite the first row and the third row because I'm not going to change those. Those are just going to stay the same right now. I'm only going to change row 2. Okay, so I'm going to add row 1 and row 2 together. -1 plus 1 is 0. -4 plus 5 is 1. 6 minus 3 is 3. -27 plus 24 is -3. So I just added them together. That's the first thing. All right, so now I have a 0 here. Love it, it's amazing. Now I want a 0 here. Well, I can't just add these things together because -1 plus 3 is not going to give me a 0. So what's the opposite of +3 would be -3. I need to make this a -3. How do I do that? Oh, well, I just multiply it by 3, right? So I'm going to do 3 times row 1. I'm going to add it to this guy here, which is row 3. And since I want my 0 down here, I'm going to put it in row 3. Just like elimination, how you would add one equation and then go from there. So I'm going to draw my little lines here. The only equation I'm going to change is row 3, because that's what I'm putting there. So I'm going to rewrite row 1. And then I'm going to rewrite row 2. And then row 3. So some people can do this next process in their head, but I'm going to go ahead and write it out for you. 3 times row 1. Well, that's -1, right? So -1 times 3 is -3. -4 times 3 is -12. 6 times 3 is 18. -27 times 3 is -81. And then I'm going to add it to row 3. So I'm just going to copy this underneath it. 3, -3, -2, and 4. And then we just add. -3 times 3 is 0. -12 minus 3 is -15. 18 minus 2 is 16. And -81 minus 4 is -77. Love it. Yes! I know you're having so much fun right now. This is great. Okay, so I have my 2 zeros here. The last thing I have to do is I need to get a 0 here. In order to get a 0 here, I have to use this equation. You are not allowed to use this equation, because if I start multiplying or adding these things together, I'm going to get rid of that 0 that I worked so hard on. So I can just use the bottom 2. So this one's actually easy. The opposite of -15 is +15. So I need to make this a +15, which I can do if I just multiply by 15, right? So I'm going to do 15 times row 2. I'm going to add it to row 3, and I'm going to put it in row 3. So basically I'm going to multiply by 15 and then add it, and then put it right there. Okay? Now, before we do that though, sometimes that step is harder. So for example, let's just say this was like a 2. Well, there's nothing I can multiply 2 by to get to 15. So I would have to multiply both of them. So that is possible where you'd have to multiply both of them to get an opposite. But on this one, we just have to multiply one of them. Okay? So I'm going to write it out here. I'll do it in red so you can see it. Actually, no, I'm not going to do that yet. What I'm going to do is I'm going to draw my matrix. And then the only thing that's going to change is row 3. So I'm going to write the top. -1, -4, 6, -27, 0, 1, 3, -3. And then now I'm going to change row 3. So 15 times 0 is 0. 15 times 1 is 15. 15 times 3 is 45. 15 times -3 is -45. Beautiful. And then just adding row 3. So 0. If you had to multiply both of them, though, you'd be multiplying right now. And then combine. 0 plus 0 is 0. 15 minus 15 is also 0. Yes, we got all those zeros. We love it. 45 plus 16 is 61. And then in your calculator, or in your head, if you want to be fancy, -45 minus 77 is -122. Yes. All right. I love it. I got all my zeros. It's great. So now that I got my zeros, now we do back substitution, which is what we did on the front. Can't we agree that this is like the x, this is the y's, and this is the z's, right? So this here means 61z equals negative 122. So if I just divide by 61, that's going to equal negative 2. So z equals negative 2. I love it. And then we go do back substitution. So 1y, or just y. And then I'm just going to do this at the same time. 3 times negative 2. 3 times negative 2 is negative 6 equals negative 3. We add our 6. And negative 3 plus 3, or negative 3 plus 6 is a positive 3. Yes. And then we go do back substitution again. So negative 1x, or just negative x. I'm just going to do this. 4 times 3, or sorry, negative 4 times 3 is negative 12. 6 times negative 2 is negative 12 equals negative 27. And then we solve. We combine like terms. Negative 12 minus 12 is negative 24. We add 24. That goes away. Negative x equals negative 3. And then if I just divide by negative there, I get positive 3. So my answer is x, y, z. X is 3, y is 3, z is negative 2. Beautiful. So I know I just did one example on the notes. There's 2 more on the back there, and then we practiced a little bit in class. Yet again, my goal is not that you're like 100% the best ever at this. It's that you kind of can practice trying to make the math happen for yourself. Yet again, if you need some extra help, come and see me.